before the meetup starts.
Hello.
Hi, Tim.
Hello.
Hey.
Hello.
Joining in from Norway.
Oh, awesome. Let me get my screen set up.
Cool.
All right. Do you see my slides?
Yes.
Yes.
Cool. My main screen is the keynote presenter, so I won't see the chat, but yeah, we're going to catch up on it all afterwards. And I'm more than happy to talk about anything Ruby. So, or to be involved in conversations among all of you about anything Ruby. So yeah, let's see what happens. But yes, I'm Tim. I'm really excited to be here today. I know it is a privilege for us all to meet in a space like this, especially with all the struggles we have going on right now. So thank you for taking the time to come along. And, I wish us all the best in trying to make our world a better, safer place. Now, as for me, as Ernesto mentioned, yes, I'm speaking to you from Canberra in Australia. And I'm really glad that the Ruby community around the world can find new ways to come together, even when the health situation demands that we stay physically apart for the time being. And yes, I'm really happy to be here with all of you today because it's not something that would happen under normal circumstances. Now, Ernesto might have answered this, but why Philly, you might ask? Well, mostly my personal connection with him. We've met a few times. I love the work he's doing, and I'm delighted to be able to contribute back via this meetup. But there's another big connecting factor, and it's this guy. With the league on hold, everyone's had a fair bit of time on his hands. So, Ben and I got to talking. He heard the work I was doing in Ruby, and he suggested the meetup. And in fact, I even ran my talk past him. So I went through all my key points, 1 point, 2 point, 3 points, but at that point, Ben said, stop, that's too many points. So thanks, Ben, for helping keep my eye on the ball here. So just a bit more about me. I'm a principal engineer at CultureAmp. We build tools to help create a better world of work. And I do a lot of Ruby there. And it's the same out in the open source world as well, where I'm part of the Dry.rb core team. And with Dry.rb, we provide a range of gems, if you haven't heard of them before, to help you write better, more maintainable Ruby code. And right now we've teamed up with the Hanami team to help build version 2 of this complete web framework for Ruby. And today we'll be looking at what is going to become the view layer for Hanami 2.0. And while this release is still in development and the overall framework hasn't been released yet, this view layer has actually been in evolution over many years, and I've personally used it in 10 or more production applications over that time. So that's why I'm really happy to share it with you today, because I think it's eminently useful from today forward. So that brings me to our actual presentation. So in the rest of our time today, I want to do something a little bit different. I want to take you behind the scenes and adopt you as fellow co-workers and bring you into a meeting because, well, after all, they're all pretty much done by Zoom these days anyway, right? So let me just get set up. I'll roll the old whiteboard in, and those markers, they look a bit out of reach. So in lieu of that, we'll just have to manage with some Comic Sans then. So, hey, thanks everyone for coming along. I know your time is precious and this meeting room's been booked solid all day, so let's get into it. We're here because we've decided it's time to do something about our views. And yes, I'm talking the humble server-rendered view. This is a qualification we need to make these days. But despite being old school, these things continue to be important in all of our apps. And I'd say they still power most of the internet. And these are essential, but in our code, they've gotten out of hand. It's why we're meeting today, because our views have just become a mess. And I know views are kind of special because they sit in this intersection between Ruby and application code and markup, between Ruby developers and front-end developers, and that does make them somewhat more prone to becoming messy. But I don't think that's an excuse. We can and we should do better. But we can't expect to continue writing views in exactly the same way and somehow expect different results. And the truth is, we've been writing views in pretty much the same way as we have since Rails 1.0 with controllers, helpers, and templates. And that's kind of damning if you think about it. 15 years have passed since Rails came to us. Have we really collectively learnt nothing since then? I mean, Rails 1.0 shipped back in 2005. This was the same year as Vin Diesel released the pacifier. Now, I know this is not the most glorious moment in cinema, but as a point of time, it's really interesting because since then, we've seen Mr. Diesel go on and relentlessly iterate. With every subsequent release of him, he gets faster and more furious, right across this whole 15-year period. But our views, well, in that time, our views have barely changed. Now, that's what makes me furious. And I don't think it's us that's writing bad code necessarily. I think it's the whole approach to views that has issues. So let's just review that situation. So we'll start with the controllers. Yes, the HTTP layer is often where we want to render our views, but it shouldn't have to be their only and forever home. That's just mixing too many responsibilities together. And then helpers, well, what can I say? It might look like we organize these things with all those modules that we sort things into, but in the end, they all get mixed together into this big global soup of implicitly interdependent methods, and we have no control over how they're arranged. And I've asked around the team, and yes, no one here feels good about having to write a helper. It's just that thing we do when we feel like there's no better option. And yeah, for a while, we tried these decorator things and we added them on and we felt that they might be a better option. And they did help, but they ended up falling into this uncanny valley of view libraries because yes, they're helpful, but they're not native to the view system. So they really lacked certain abilities. And because they were opt-in as a facility, there was always a little bit too much friction around using them. So we didn't turn to them often enough. And this lack of good options in the end meant we had too much logic cluttering our templates, when these are places we should be much rather focused on markup, structure, presentation, not complicated view logic. So I think this just means it's still too hard to write good view code with these tools. And really, what we should be striving for here is for our view code to be good anything code. Just because we're writing in the view layer doesn't mean we should sacrifice all the good principles that we apply to the other layers of our code base. So let's fix this. It's why we're here today. Let's build a better view system. And of course, we should publish it as a gem 2, and we'll call this one Hanami View. Okay. Now, I appreciate all of you taking the time ahead of this meeting to consider everything and send me some requirements you have for building better views. And after looking them over, I think there's a way we can bring them together into a nice, coherent system. Now, first up, you said a view needs to be a thing, an object, something that we can address directly and pass around our application. So let's start by defining a class for our view. We'll inherit here from Hanami View. And then yes, it looks like we can make this into an object in typical Ruby style. And then we'll make it so our views can have dependencies injected as well. This means they can go on and cleanly collaborate with whatever other parts of the app they might need to go ahead and do their work. So here we're building a view for showing an article. And in this case, we might want to give it an article repository so that the article in question can be loaded from the database. And then we'll pass that repository in when initializing the view, just like this. So now we have views as objects. The next thing you said is that we should be clear about declaring the values we make available to our templates. So we can solve this by adding exposures to our view. And in this case here, we'll want to expose a single article to our template. And inside this exposure, we can do whatever we need to prepare the value we want to pass along. So in this case here, we'll expect an article slug to be passed in, and then we'll use that slug to load the matching article from the database. And that is our value. And then if we're going to be passing this to a template, let's give ourselves a place to configure the template's name. And that brings us to our next requirement. We still want to build our views on templates. We're comfortable working with them, and they're still a great place for our front-end developers to go to work. So here's our template. This one's written in the Slim template language. And what we're doing here is we're putting a header on our page and using that article we exposed before to fill in its contents. Now with that template in place, we can go back to our view object and call it, passing in that article slug. And look, hey, here we have our rendered view. And so that's it. I think we're done and we can move on to the social aspect of our meetup, right? No? Okay, you're saying we've got the basics done, but there's more we can do. It's clear we wanted templates, yes, but we don't want those templates to get mired in some morass of complex logic that weighed us down before. What we want is for our template code to be simple and for us to push as much logic as we can into other places in our view system. So let's look at some aspect of this logic here. Here's how we might have used a helper before to render the article's body from some markdown. Now, the downside to using helpers like this is that we have to remember to use them in every template that handles these articles. And then the accumulation of hundreds of these things over a range of different concerns is part of what got us into this mess in the first place. Now, this is more like what you wanted to see in templates. The view-specific behavior hanging off the values that we passed to the template in the first place. And yes, this is some kind of decorator object, something that wraps the value passed in from the exposure and then carries any extra view-specific behavior along with it. So let's build one of these up. We'll call these view parts. And this one here will carry the view behavior just for articles. So this gives us a place to write that body HTML method right there alongside the article's own data. So now we've simplified our templates and we've taken care of the other side of that equation, which is to decorate our values with objects providing view-specific behavior. Now, this next requirement, it's interesting. I see you surveyed how we used decorators before, and you realized a decorator is only so good if we actually use it. What you want is a system that nudges us towards the right abstractions every time, with decorators being made available automatically right from the beginning. And I think I found a way we can make this work. If we configure a part namespace on our view, then we can make it so that every exposure in that view is automatically wrapped in a matching part object. So all we need to do from here is create that part class and it'll be picked up automatically. Now this means we'll be much more inclined to turn to parts when adding view logic because they're much lower friction. So I get what you're saying here. If we're going to do our own take on decorators, we need to make this worthwhile and close the gap that we felt when we were using those bolt-on decorator systems before. What you want to see is view parts become fully integrated with the rest of our view system so that anything you can do in a template, we should be able to do in a part as well. So let's find a way to make this work. We'll go back to that article template and say we needed to put some sort of social sharing widget at the bottom. Classic client request, am I right? Now, the markup for this is pretty tedious, and we have to remember to pass in all the different aspects of the article that are necessary for the widget to appear properly. Now, at this point, we could realize that this is kind of a self-contained component and something we want to reuse, so we can extract it into a partial. And yes, we have partials in this system here too, and we can call them using the render method. But even with this partial in place, we still have all this awkward attribute passing we need to take care of for every single use of that partial. So how about this? What if we could render partials from inside our view parts, just like we can in our templates? Well, then we can move everything into the articles part class and hide away all the particulars of the rendering, that low-level detail that we don't really need to know in the template. And that means we'll have a much cleaner, more intention-revealing template in the end. And this is the benefit we wanted to see from having view facilities that are fully integrated. So things are feeling pretty good now, but I still see a few of you pointing out a gap. With view parts, we added an approach for view-specific behavior around values. But what if we wanted to add custom behavior around a particular template or a particular partial? Now I noticed one of you brought up an example where something like this could help, like here with this related article partial. Now, this rendering looks pretty innocuous at first glance, but if we go and dive into that partial, oof, this is some pretty hairy looking template code. That's some logic I just don't like to see in templates. And if I look closely, I can see what we're trying for here. We want to provide some default values when this template is rendered without one or two of those locals passed in. But this really feels like the wrong approach for something like this, right? But hang on, this code looks pretty familiar. Just a second. All right, that one's on me, but I'm glad we're working on this together because you thought of a concept that can clean all of this up. Alongside our parts, we can add another concept and we'll call them scopes. So let's build up a scope for this related article partial right now. So while parts deal with single values, the idea for scopes is that they deal with whole templates or whole partials. So we'll give them access to that template's complete set of locals. And that gives us the chance to write methods that can properly handle the case of a missing local and providing a default value. Like this one here for whether or not to show the author. In this case, we default to false unless told otherwise. And then this one here, which provides a default for the link's prefix text. And again, the default value is the string related if none is passed. And then we can go ahead one step further and combine the prefix text with the article title for us to return the full link text in one go. So that means we can say goodbye to that founder's code of mine and end up with this much nicer template using all of the scopes methods to keep it tidy and intention revealing. And then to make sure our partial is rendered with that custom scope, we want to build the scope first, still passing the same name, still passing our article to it. And then we can tell the scope to render itself and it'll pick up the matching partial and go to work. So this list is looking pretty complete now. I think we must really be done at this point, right? Wait, some kind of helpers, really? After everything we've been saying? All right, I see you make a fair case. It's likely there might be a small number of things that are truly common to all views and all templates. Some kind of baseline rendering context. Well, let's take that idea and make it the name of this new facility, a context object. And then just like our view objects themselves, this context might need to interact with other parts of our application. So we can make those available by injected dependencies as well. And in this case here, we're passing in an object managing a static assets manifest, the kind of thing that Webpack or some external asset system might generate for us. And then we can add a method here to work with the manifest and give us the full path for any given asset. And then to tie everything together, we need to make it so that whatever methods we define on this context class are available to use within any template. And then since we want every aspect of our view facilities to be fully integrated, we can make it so those context methods are available in both parts and scopes as well. So this means we can continue to keep our view logic in all the best possible places while still taking advantage of every feature of the view system. And I like this point you make about this class as well. While those methods might feel like helpers in regular usage, that's the only thing they share in common with our arrangement before, because in practice, these are just regular methods defined in a regular class with its own state and its own clear dependencies. And that's something that we can keep on top of and easily refactor over time. Well, now I think we've made it. And it's not just because we're out of space on the whiteboard. I think we've given everything this system needs. And we did it by working through our requirements one by one, and then discovering the concepts around which we should organize our views. We started by realizing we needed views to be objects unto themselves, something that can carry the specific configuration, dependencies, and its exposures. And then those exposures should go ahead and clearly prepare the values that we want to pass to the templates. And then the templates and partials still exist, but we've made it so they can contain just the markup that we need. Because we now have parts which carry view behavior intended to live around particular values. Now we have scopes which add extra behavior around specific templates. And then finally, we have that context object, which provides the baseline rendering environment and ties everything together. So at this point, I think we should take a step back and ask, well, what did we learn through doing all of this? Well, I think we rightly recognized that views are complex. And they're complex enough that templates and helpers are just not up to the task of handling them. In working through our requirements, we created a whole 6 different places to keep our view logic, with each one serving a distinct, necessary role. And this wasn't just architecture for the sake of it. This really feels like minimum viable views. Every one of those structures exists because it helps us to write better view code. If we take any one of them away, that code will need to be put somewhere else, which will invariably see things getting worse. And the benefit from having all these structures available right from the get-go is that they make the easy thing to do also the right thing to do. And it's when these things align that the quality of our code can really improve. Let's just look at some of the outcomes here. By representing our views as standalone objects, injected with other parts of the application as required, we've enabled a clean separation of concerns. We've disentangled the views from the rest of our app, letting them stand apart in a truly distinct layer. And then by moving the bulk of our view logic into part and scope objects, at last we're properly encapsulating that logic, combining the custom behavior with the data that it relates to. And all the different objects that we looked at in the view layer today, they're designed to be immutable. Once they're initialized, their state will never change. That makes them easier to understand, and it gives us a much clearer to follow flow of data through our views. And all of this makes for a view layer that is far easier to test than ever before. In fact, we can unit test more of our views than ever before. And we can do this at whatever level of granularity makes the most sense. If we have some part classes or scope classes with some aspects of complex behavior, well, we can unit test those methods directly. Or we can even test a view object in full by building up the object, passing in some test values as its dependencies, and then asserting against its output text. So we can test this view in complete isolation, not requiring any web request or any request going to the database. And it's this ease of testing that really brings home the lesson here, that better view code is better object-oriented code, full stop, period. We should strive for this in every aspect of our applications. The view should be no exception. And better object-oriented code means we have views that are a joy to build again. These are views we can be proud of, views that we can trust will work the way we intend, right from the beginning. And this is what helps us build better applications. And whether folks out there use Hanami View or not, hopefully some of these ideas can at least help push their views in a better direction. Because what we've done here is about more than just building apps. It's about creating a better, stronger Ruby ecosystem. Because in making a new view system, we've created choice. Choice leads to diversity, and through diversity, we encourage the healthy sharing of ideas that drives our community forward. And importantly, what we created here is open to everyone because it's a standalone system. As long as you use Ruby, you're good to go. This thing will fit nicely into Hanami, the framework, yes, but you can also use Hanami View inside of Rails or Sinatra or even on its own. However you want to use it, it's all good. And then once you use it, how you use it is also up to you. Yes, obviously you might want to render web responses as views, but you can also use them to render emails or really API responses or anything you like. because this thing is a standalone, it's flexible, which means you can integrate it however you please. And in building this, what we've done is innovated in a space that's been largely stagnant for 15 years. We felt the existing tools were getting in the way of us writing good Vue code, so we did something about it. And the solution, well, it turned out to only be about 900 lines of code. This wasn't rocket science. Anyone could have done it. So in doing this, we've shown everyone that yes, while Ruby might be considered a settled language ecosystem, there is always the opportunity to take another look at something fundamental and offer a new and interesting take. So what did we do? Well, we invented a Hanami Vue 2.0, and we gave ourselves a chance to write some better views again. And with that, I think someone wants the meeting room, so we should wrap up. Let me just share some notes. I'm Tim. Find me on Twitter there. Thanks so much for coming along. On my website, timriley.info, I've started doing a monthly open source development diary. And right now I'm heavily involved in improving the Hanami Vue and controller layer. So, and making those as nice and low friction and boilerplate free as possible. So if this is something you're interested in, that could be a good place to follow along. And if you'd like to maybe try using Hanami Vue today, the best place would actually be to go look up the Dry.rb website and read up on the gem there called Dry Vue, because this has actually been a renaming effort. Dry Vue is moving into the Hanami organization and being renamed, but everything we talked about today exists within the most recent release of Dry Vue. So you can use either one, and the documentation there is a great way to understand more detail about all the concepts I introduced. So again, thanks for coming everyone, and I'll see you at tomorrow's stand-up.